This is lesson 2-7 and it starts in your workbook on page 134. This is example 1 on page 134. It says the students in Meg's class are building a fence around a class garden. How can they use the pricing for different lengths of fencing to determine the cost for 50 feet of fencing? All right, so we have some important information here. We want 50 feet. We know 6 feet is 30. We know 15 feet is 75. We know 24 feet is 120. Now, as a little bit of a review, let's think back to unit rate. So in unit rate, we simply would have taken the money divided by the feet. So this looks like it's $5 per foot. This looks like it's $5 per foot. This looks like it's $5 per foot. So I almost feel like we could just take 50 times 5 and get our answer. But this lesson has to do with slope and not unit rate. So let's move on. When we've been dealing with slope, we've been dealing with graphs. And so they took that information. 6 feet of fence is $30. 15 feet of fence is $75. 24 feet of fence is $120 and so forth. And it would make sense that it would go through 0, 0 because no fence would cost no money. So this is a proportional graph. It is straight and it goes through the origin, which means the slope is going to be the same no matter where I am on this graph. Now we learned in our last lesson, that I could simply count up from 0 to 75 and count over from 0 to 15. I could divide and I could find that this cost $5 for every foot of fencing. Now that's called slope, or last year we would have called that the constant of proportionality. Now last year, for our constant of proportionality, we had an equation that looked like this. And every time we found our unit rate or our constant, we put it right there. Well, this year we are doing slope. And its equation looks like this. And sometimes I really feel that we make math a little more complicated than it needs to be for kids, because slope and constant proportionality are exactly the same thing. So we should be using the same equation. But regardless, your slope is going to be your multiplier. And so if I wanted to write an equation for this, I would say y equals 5x would be my equation. The x, remember, is my length in feet. So the question said, how much would 50 cost? Well, 50 is going to cost $250. We got that 3 different ways, actually. We got it through unit rate. We got it through constant of proportionality. We got it through slope. And technically, we could do it one more way. We could go over to 50, head up to our line, and get 250. There were a lot of ways to answer this question. This is the try it on page 134. Write an equation to describe the relationship shown in the graph. All right, so if you remember, my equation is y equals mx, where m is my slope. You could call it a constant of proportionality. You could call it a unit rate, whatever you want to call it. So I am going to use 0, 0, and I'm going to use this graph to help me. And I'm going to find my slope by doing rise over run. 20, 40, 60, 80, up. 1, 2, 3, 4 over. 80 divided by 4 is 20. So my equation is y equals 20x. This is example number 2 on page 135. A drone descends. That's important because you're going to have a negative slope. In fact, look at your graph. Do you see how it looks like it's going downhill? That's an important indicator that your slope is negative. Anyway, a drone descends into a mining cave. The graph relates its distance below ground to time. Write an equation that describes the relationship. All right, so your book is going to use ordered pairs. They are going to use this ordered pair, and they're going to use this ordered pair. And there's absolutely nothing wrong with that. I am going to choose to use this ordered pair and this ordered pair because I love the origin. So I'm going to use 0, 0, and 1, negative 250. If I subtract my y coordinates, 0 minus negative 250 on top, I could subtract my x coordinates, 0 minus 1 on the bottom. 0 minus negative 250 is a positive 250. 0 minus 1 is negative 1. When I subtract, I will get negative 250, just like they did. So no matter how you went about getting your slope, you could have counted. You could have used different ordered pairs than I did, or you could use the same ordered pairs that I did. No matter how you do it, your slope is negative 250, and it lives right there in the equation of y equals negative 250x. This is example number 3 on page 135. A recipe for trail mix calls for 1 cup of raisins. Let's just find our labels. 1 cup of raisins for every 2 cups of granola. Write an equation that describes the relationship between raisins and granola. Graph the line. Okay. So, what they did was they figured out that we are going to do the 1/2 ratio. 1/2 ratio is our slope, and the slope goes right there. So they did y equals 1/2x, and then to graph that, you're always going to start at 0, 0 for a proportional graph. You go up 1/2, make a dot. Up 1/2, make a dot. And then keep going until you can connect your dots. This is the try it on the bottom of page 135. We need to write an equation for A. That's pretty simple. I know my equation is going to be y equals mx. I know that is my slope, and I know how to find the slope from a graph. I'm going to pick 2 dots. I'm going to pick this one, and I'm going to pick this one. And although I could use ordered pairs, I'm just going to count it out. I'm going to go up to 4 and over to 10. Now that's an okay equation, but I think I can do better. I think I can make it y equals 2. Oops, I forgot something there. Y equals 2/5 x. I think that's probably the better of the 2 options because my slope is in simplest form. All right, let's make, instead of an equal sign, we have too many equal signs, maybe we'll just make an arrow. That became that. All right, on B, graphing it. Now this one's a good one. So here's our equation. Can I just remind you that there's an invisible number 1 right there? Can I also remind you that we're going to start at 0, 0? Can I also remind you this is my horizontal or my y change? In this case, I didn't say rise. only because there's a negative. So instead of rising, we're going to be falling 3. And this is my exchange or my run. So I can still sort of think of that as rise, but I know it's negative over run. So I'm going to start at 0, 0, and I'm going to fall 1, 2, 3, and over 1. This is going to be tricky with my fat pen because we're counting by 2s on this graph. Count down 1, 2, 3, and over 1. Count 1, 2, 3 over 1, and it's going to look something like that. So I counted 3, right 1, down 3, right 1, down 3, right 1, and I connected my dots. This is your key concept on page 136. We know this is proportional because it hits the 2 criteria we learned last year for constant of proportionality. It is straight and it goes through the origin. Last year, with our constant of proportionality, we used this equation. Now that we know about slope, we're going to use that equation. That is your slope. So slope, remember, is rise over run. So your equation is going to be y equals slope times